if I use total amount xt, the unit is gram of x. If I say initial x naught t, still gram of x, right? So these are the steps for you to answer. Not all of the steps are useful to answer P, but it will help you to understand what happens in fat batch. It will help you to understand what happens in fat batch, and they are all explained in the video which I uploaded in Ireland. You need to go back and re-listen. Okay? Now, first, derive volume. What is fat batch? Why do we need to derive volume? As if there is a special equation for volume. What is fat batch? What do you do? What do you do? What do you do? Saying this is fat batch. You what? You keep feeding nutrients. Yes, you keep feeding nutrients. Why do you want to feed nutrients? You keep feeding nutrients to get a constant product. We are not going to get a constant product. We are going to get as much as possible product. Of course, we need to promote the growth of the microorganism. You want to promote, right? Because you putting the substrate nutrients, you are promoting them. But you want to achieve as high as possible P. You don't want to achieve constant P. You want to achieve as high as possible P. Can you do that in batch? Yes. You can get as high as possible X. From X you get the P, right? But the X achieved from batch depending on how much initial S you have, right? Substrate. But what happens in batch? You put everything in with specific concentration of substrate, then you introduce inoculum, let it grow until it dies, then you measure the X, right? And you measure the P. That is the maximum P that you can get from the X. Can you further increase this X? Yes. You are not satisfied with this X. So but now the X are all dead. So you repeat the experiment. You are not going to let the X to die. The X die because no more substrate. Fat batch starts from batch. So you have your batch with certain volume. T equals to 0 until Tn. That is your normal batch. But you don't want to let it end when the X die, right? You don't want this. So you are going to... What happens in batch? You have your time, you have your X, right? So your X is somewhat like that, right? So what happens to here? This is X maximum. Can I see the graph? Oh, that is X maximum. So what happens at that point? The S is approximately close to 0 because it is exhausted. When S is close to 0, it means why I write at N? Okay, that doesn't matter. The X has reached its maximum for concentration. Alright, so I'm going to write it in the next slide. This is your batch. So go back to your next slide. That is your X maximum. This is your X maximum. That is the point. If you don't fit in new nutrients, it will enter stationary and it will start to die for the next few hours. So you are not satisfied, you are not going to let it die. You feed in more nutrients through volumetric flow rate and at certain S naught. So this is the end of batch. So at the end of batch, you achieve XM, meaning you achieve certain yield of X to S, maximum yield. At this point, with this, you start your fat batch. So I'm going to go to the next slide. Can we? So this is your fat batch by feeding F and S naught and certain X naught to your certain volume initial from batch. Yeah. So this time is now equals to 0 for fat batch. The initial time when you start your fat batch. Now, during batch, you start with XM. And what is this equation of XM? Meaning you start from the yield maximum of X to S. Meaning you start from a certain yield, right? So what is that equation of yield? Minus X minus S naught over S minus S naught. X minus X naught over X naught minus S, right? When it reaches its maximum, you are saying the S is now 0. Exhausted. And when you assume X naught is sterile, feed, that is also cancelled based on your assumption. So your yield maximum of X to S times the S naught is equivalent to XM. Now this one becomes maximum when you make this assumption. When S is nearly 0. This is what you see, right? This is what you see. Maximum. Okay? Alright? Now, for start of batch, you feed in certain flow rate, right? Volumetric flow rate in terms of liter per hour. So what happens to the volume? Let's say this is your V naught. You feed in F, S naught and X naught. So what happens to the volume through time? As T increases, volume increases. So the volume will slowly increase. V1, V2, V3. Right? Okay. Now, what is the other rule of fat batch? You go for fat batch because you are not satisfied of the X concentration, right? You think that is the maximum yield for batch. By adding new nutrients, you predict that the X will increase. Why is it increase? Because you are feeding more nutrients. Now the next question is how to feed the nutrients to the maximum X. Yes, with certain flow rate. And the next question is what is the best value of liter per hour? The next question is what is the best value of S naught? Let's say you choose a certain value of S naught. What is the best liter per hour? Should it be high or low? If I'm talking about F, should F be high or low? Can you please read the definition of fat batch? Do you have any definition of fat batch? What does it say? Yes, fat batch is, Mr. Jeremy, can you please read out loud? Jeremy. Jeremy, no, don't say that. Jeremy, saya sila sebut ke? Yes, you want to maintain low substrate concentration. What do you mean by that? concentration. You feed in certain liter per hour at certain concentration of S0. But now he says to maintain low substrate concentration. Where is that? In the reactor. Why you want to maintain low substrate concentration? Imagine what you have inside here. You have here XM, right? XM means a lot of gram of X per liter, a lot. But then in the beginning, the X is nearly 0. But you suddenly introduce certain S0. When you say you want to maintain the substrate concentration is low, to be low, it means you are maintaining this one. You are maintaining the S is nearly 0. The S is always low, always reaching 0. Why? Because the cells are a lot. Suddenly you supply substrate. But the substrate is supplied at a very low flow rate. So they are consuming the S, whatever S is being fed continuously through time, but it is always not enough. It is always limiting. But it is being fed. Mati ke tak mati? Mati. Jadi sikit, tambah sikit. The X is increases, but the S is being consumed. But what is the best S0? Itu yang orang investigate the lab. But the key point of fat patch is you are supplying it at a very low flow rate. That is one thing. The other thing is, why low flow rate? Because flow rate means liter per hour. You want the X to increase as much as possible. Meaning, you want more time so that the X replicate. When the volumetric flow rate is low, tak sempat lah dia penuh reaktor tu. Betul tak? Sikit, X pun tambah sikit. Sampailah maximum level of volume of the media in that reactor, because you already know the size of the reactor, right? When it reaches its maximum allowable volume, contoh ni by theory ya, let me stop the experiment. Either that or you monitor the X tu tambah volume tapi X tu stay, maksudnya tu dah maksimal tu, stop lah. You tambah volume, X tu naik, ya tambah lagi, naik, it doesn't stop, so that is increase. That is the engineering behind. Alright, understand? Can we further continue before? Do you have any question before we continue? No. Now, so this is what happens in fat batch. The F is low at certain S0. The F is low, liter per hour. Alright, meaning through time, as T increases, the volume increases, the X increases. Alright, so what changes through time? V and X both change with time. Both change with time. Okay? Time. Now, go back to our exercise. How to derive V? Meaning, the V is another equation. The V, the volume of the fat batch reactor system, is influenced by something. The V, you know, the V changes with time, right? So how do we do that? Number one, yes, the V dV over dt is equivalent to F. This is liter per hour, this is liter per hour. Liter per hour. Now, how to get V? Yes, dV is Ft time. F is constant or change? F changes or F is constant? Constant. Constant liter per hour. Okay? So you integrate. So what do you get? V minus V naught equals to F T. T minus T naught. Alright? T naught is 0. So V equals to V naught plus Ft. So that is the equation for volume. The volume depends on the initial volume from batch plus Ft times F times T. Okay, what is that? The initial volume plus liter per hour times how many hours? So you get liter, right? The initial volume plus the extra V from the feed, right? That is easy. Next, second one. How do we write the material balance for X? The material balance for X, it means how much of gram of X per hour. Material balance for X. So we have a reactor, fat batch, we have F, we have S naught, we have X naught. Alright, as T increases, volume increases. Right? And of course we know X increases, right? Okay? So material balance of X, rule of thumb is in minus out, plus or minus, it depends on what we are talking about. So what are we talking about here? The X. So the X should increase or decrease? Increase. So plus of what happens to the X inside, increasing X, equals to the accumulation based on time. Alright? The accumulation of whatever. We're talking about X, right? X. Now, what comes in? Remember each term must be expressed by gram of X per hour. What goes in? The F, right? The F, this is liter per hour. How to get gram X? How to get gram X per hour? You need the X, right? What X? So this is gram X per liter. You get gram X per hour. What X? What comes in? X naught. Fx naught. Do you have anything going out? Do you have anything going out in fat batch? No. So what happens inside? We say positive because we say the X increases. The X increases, right? What is the gram X per liter? 1 per hour, right? So the X increases by 1 per hour. Gram X per hour. Do you need liter? You don't need. So you have to multiply by liter. What is that? What is this? Volume. Equals to accumulation. The accumulation of X over time. Alright? But the X increases with different volume. Through time, the volume changes, right? Right? So this is, let's say X. Gram X per liter hour. Betul? Right? But now we have another parameter which is changing through time in the reactor. What is the other parameter? Of course, we have parameter time. Now we are saying the X changes and the other one is also changing. What is that? We need gram X per liter, so we don't need L, right? So volume there, V. But does V change through time? Yes. So how do we write this? Both are changing through time or with time. So how do we write? Huh? When two parameters are changing at the same time with time, with time. So two parameters must be written as a product, not plus, product. So it's a product of two parameters. What is that? The change of two parameters with time. So it's a product of that two parameters. E of x times v. Now, so the final equation is Fs naught plus V mu x equals to d over d time of x and v. Alright? Now, when we have this material balance, so what do you do with this material balance? You need to simplify, right? By making assumptions. What is the easiest assumption that you can make about x? When it reaches the x reaches its steady state. In fat bash, does it really reaching its steady state? The volume is changing. How can it reach steady state, right? The x also changing. But to simplify things, we can assume, we can use quasi steady state assumption. We want to assume the x over dt equals to 0. But by right, it is not steady state because the volume changes at the same time. So we say quasi steady state, whereby dx over dt equals to 0. That is one. So how are we going to use this assumption in this equation? Do we have any dx over dt there? Where? So what do? You have to open the, you have to solve the differentiation rule. So which rule do you use? Product rule. Product rule of differentiation. So what is the product rule of differentiation? Let's say d over dt have fx, two functions. You still remember? No. So what do? One function you stay the same times, the other function you differentiate. Plus, the other function you don't do anything times, the other function you differentiate. Remember? Or if I say this one is A, this one is B. So d over dt of A and B. So it means A dB dt plus B dA dt. So can we do that to, can I go to the next slide? Can I go to the next slide? No, yes? Yes. So we are going to rewrite V mu x equals to dxv over d time. So we are going to solve the right hand side equation, which is, we know that dAb d time is a dB over d time plus b dA over d time, right? So now solve this one. X dV over d time plus v dx over d time. Your first assumption is quasi steady state, whereby dx over d time equals to 0. So can you now cancel any term? No? Which one? This one, the first one or the second one? The second one. That is 0. So you have f x naught plus v mu x equals to x dv over d time. Now, second assumption is when you say sterile fit x naught equals to 0, right? So what can you do? The first term here is cancelled. So v times mu times x equals to x dv over d time. So you have x both sides cancel out. So mu is equivalent to bring the v to the other side. 1 over v dv over d time is mu. What is dv over d time? The change of volume over the time. So what is that? Yes, volumetric flow rate. 1 over V equals to mu times F, which is F over V. And what is that? Yes, dilution rate. So therefore, the mu is equivalent to the dilution rate. You do this when you assume here in the beginning KD equals to 0 because you only consider the mu. You don't consider the KD. But you can write what happens inside if you say KD exists, and of course you have mu. Mu is the growth of cell. KD is the death of cell. Now we say cell don't die, only grow. So we only write mu times x. But right, mu net is mu minus KD. When KD equals to 0, so mu net is mu. And now the mu is D. So mu net is D. And mu. Okay? Now, the second question asks you to derive mu. The answer is mu is D. Right? Mu is D, D is mu. Huh? Oh, divisibility to you told me earlier. Right? Yeah. Right? You are the one who engineered this. You gave it certain liter per hour, and that certain liter per hour is added to the initial volume. So what happens to the volume? Volume increases. So the change of volume through time with time is depending on the F. Right? The F is actually changing the volume. So the F is dV over the time. Can I go to the last slide? Yes. So, can I go to the previous slide? No. Yes or no? This one. By relating to Monod equation. Okay, how to relate to this Monod equation? But the equation is a little bit... Sepatutnya by relating to Monod equation is to help you to derive the S. Now, how to get the S? Now, you know that mu equals to D. Mu is specific growth rate. If mu is the specific growth rate, the X increases following what theory? For bacteria, for example. For microorganisms. Monod theory. Monod equation. What is Monod equation? Mu is equivalent to S over Ks plus S. That is Monod. And the mu now from the metric balance is D. Okay? So can I go to the next slide? Yes. We are going to rewrite the Monod. Mu m S over Ks plus S is mu, and the mu is D. It is mu, right? From here, mu ms is mu Ks plus S, which is mu Ks plus mu S, mu ms, right? So we want to derive for S. What is S? What is S? So you're going to gather S together, right? So mu ms minus mu S equals to mu Ks. So mu ms minus mu is S. mu Ks. S is mu Ks over mu M minus mu. That is S. And you know mu is D. So mu Ks over mu M minus D. So the mu is actually D. So Ks times D is over mu M minus D is S. Is Ks times D. So this is how you derive your S. By relating it to Monod equation. I will go back to our exercise. Now, derive total amount of biomass. This is a little bit longer. To derive the total biomass. But the basic rule is what? What is the basic rule of writing the equation of xt? What is the unit for xt? Gram x. What do we have so far? We have x. What is the unit for x? Gram x per liter. What do we have again? V. Liter. How do we get gx? Gram of x. xt is equivalent to, by using this two, for example. By using those two last parameters. Don't look at your notes. Look at the slide. Am I blocking it? So how to use xt, x and v to express xt? Yes, x times v, which is gram of x per liter times liter. Right? So the x in fat batch, the x is actually xt over v. Now, if you were to say, okay, the xt is simply x times v. What is v? V is, what is there any equation for v? Is there any equation for v? Did you derive v just now? V naught plus st. Right? So what do you have here? X v naught plus ft. That is xt. Now, the really needs to ensure that you understand, because we are going to use